the talks. Okay. So, good morning. Thank you, everybody, for coming. I sincerely apologize for the failure in planning with this rain and cold weather. We really tried, but the coldest week of the year is exactly this year, apparently. But as I promised in one of my emails, we'll keep you warm here with hot discussions. So I want to first thank the Institute of Advanced Studies for a wonderful semester of hosting the research group called Deconstructing and Reconstructing Consciousness. The members of the group were Lucia Meloni, Daphna Shohami, Mike Shadlen. Where is Mike? You should be sitting here. Mike Shadlen, Rafi Malach, Ran Hassin, and myself. And we spent 5 months of intensive discussions with a few other guests, Lionel Nakash, now Tuchia, Timo Stein, and Norbert Schwartz, who came for some time. And this was like amazing experience. I recommend to each of you, if you ever can be one of these groups, please do yourself the favor and do it. So the people behind this are Iris and Yitzhak, who are running the institute, Anat and her other colleagues who are wonderful organizers, and they are actually responsible for all the logistics of this conference. I'm really indebted to them. It has really been a wonderful way of organizing a program. We just said we are going to have a conference, and they did the rest. Okay, so it's fantastic. We also have to thank especially Michael for organizing the live streaming to the other room. We expect more guests after following the rain. And we have a spillover room, and it's all broadcast in YouTube. And also Yossi, who's not here, but you should convey our thanks for him for taking care of all the hot water problems, heating, and very important things for our well-being during this time. Last but not least, I want to thank Gal. Where is Gal? Who was our research assistant and kept us going and kept this whole thing really working. And finally, I want to tell you what Gal asked me to tell you is that we have a hashtag for Twitter. If somebody really feels like conveying to the world what is going on here, the hashtag is DecRecCon. And like deconstructing, reconstructing consciousness, DecRecCon hashtag, and please use it. And now I want to invite Itzik Chen, the head of the institute, to say a few words.
Welcome to Jerusalem and to the Israel Institute for Advanced Studies. I'll tell you a bit about the institute before I'll leave you to your conscious discussions. The institute was founded in 1975, so it is one of the earliest institutes of advanced studies around the world, apart from Princeton, which was founded in the 1930s as a safe haven mainly for scholars who came over from fascist and Nazi Europe. The idea behind the institute here was again to create a safe haven for scholars who wanted to work in groups and to promote their own research and develop and advance new fields or create new fields in their own small sphere. And ever since its foundation, our institute hosted more than 150 research groups and over 2,000 scholars. So this is the main activity of our institute, and the group that really originated this conference was, I should say, one of the most successful ones. We've seen them. They were very active, and we encourage that. This is the main activity of the institute. Apart from that, we are hosting advanced school for PhD students from all over the world. We have 6 of these in various topics each year. And of course, conferences which are related to our research groups, and this is the conference you are here today. I'm not a psychologist, although I have 2 degrees in psychology from the Hebrew University. But in a conscientious decision, I've decided to become medievalist, and I'm studying early medieval history. So I can tell you that the notion of conscious was first raised by a guy called Macrobius Ambrosius Theodosius at the beginning of the 5th century. And he was actually trying to look at what the various states of consciousness when people are making decisions. So of course you can see here his diagrams of what are the processes that influence consciousness. The things are rather different from what you are looking for, because he has the stars and the earth and the elements and things like that as things that are influencing consciousness. And you can see this is one of the charts that according to which, if you analyze it properly, you can, according to his theory, you can see what decision people will make. So that's more than 1,500 years ago. You have a different notion of consciousness. And all that is left for me to do is to welcome you to the Institute and wish you a fruitful discussion today. Thanks.
Just a few technical points. So we have tonight a reception at the end of the day here downstairs, right? Downstairs at the Institute. I welcome everybody to join us for this reception. For lunch, there are a few cafeterias just next door to here, so you can find your favorite food. We're happy to help you find these cafeterias. They're all within walking colonnades, so you're covered from the rain on your way to the cafeteria. And other than that, we are going to have now a series of talks. We organized it such that we have 45 minutes for each talk, including the questions, and I encourage the speakers to limit themselves to about 30 minutes of talk and leaving a lot of time for discussion. So with that, we start the first session. Rafi will lead it.
Welcome all, and I'm pleased to open the first session. I will give a ring at 25 minutes just to give the speaker an idea of the time goes by. So I'm pleased to invite the first speaker, Professor Orly Shenker from the Hebrew University. And the title of her talk is the Mind in the Brain According to Contemporary Neuroscience?
The microphone. Can anyone help me to put my slides instead of these ones?
This is you attached to your. Okay. That means we cannot move away from this.
This is it?
Yeah. It's not on yet. Okay, good. Let me start by, apart from thanking the organizers for inviting me here, let me say that I'm a philosopher, and so it takes a huge amount of chutzpah to come here and tell this audience something about contemporary neuroscience. So please indulge me for this chutzpah, because I'm really going for it. First of all, this work is a joint project with Meir Chemo from the University of Haifa. And when we're talking about the mind and the brain, for us the mind is everything that is mental, where I'm not distinguishing between sensations, thoughts, etc. All of those are the mind. And when I'm talking about the brain, I don't care about the limits, the physical or physiological limits of the system. Anything physical that may be relevant, whatever it is I will call the brain. And so the question is about the connection, the relation between the mind and the brain, broadly speaking. And in traditional philosophy as well as science, as well as contemporary philosophy and science, there are three major families of ideas about this connection. One is what here I call reductive type identity physicalism, by which I mean the mind just is the brain, mind, mental states and mental processes just are brain states and brain processes. The second view, or the second family of views, is mind-brain dualism, according to which there is something in the world, there are some facts in the world that are above and beyond the brain, whatever the nature of these facts may be. As long as they are not purely physical, they are something else. This I will call dualism, and we will see examples later on. The third family of views, which is, I think, the most prevalent, the very popular, the dominant view nowadays in philosophy as well as in science, is varieties of so-called non-reductive physicalism. Non-reductive physicalism are all the approaches that allow for multiple realization of mental states and processes by brain states and processes. And I will explain very briefly what that means in a minute. In this family, we include functionalism, both computational functionalism and causal functionalism, where computational functionalism is what is by and large done in computational neuroscience. So this is a major topic. This field of research is a major topic of this talk. Here, when I talk about computational neuroscience and computational functionalism in general, what I mean is that the idea that mental processes are identified with computations. I'm not talking about computerized simulations, etc. Simulation is something else. This is an identification. The computation is mental, is the mental. Functionalism is a very complex view. I'm not going to explain all its aspects, but I am going to ask two questions about functionalism, and I will focus on computational functionalism, but whatever I say applies also for causal functionalism. Causal functionalism is, for example, the view that is applied when people talk about genuine neural plasticity, that the same mental state or process is implemented by two different physical states of the world. But I'm not going to talk about the causal functionalism, but only about computational functionalism, just to be more brief. So two questions can be asked. If functionalism says, computational functionalism tells us that different systems, for example, human brain, octopus brain, and the computer motherboard, can implement this, in principle, the same computation, and we're looking at brain processes as being computations, then we should ask two questions. The first question is, which computation does the brain realize or implement, and which physical facts fix this computation? So when we look at a physiological brain, the question is, what is it doing in terms of computation? Of course, the same question will apply for the octopus and the computer motherboard. The second question is this. Since we have here, in this example, three physically or physiologically systems, we should ask what makes them a kind, in virtue of what are they implementation of the same mental state. So in virtue of which physical facts in particular do all these cases realize or implement the same computation. And I emphasize that I'm interested in the physical facts in both questions, because the question is whether the approaches that are under the heading of computationalism or functionalism more general are physical approaches. Are they one of the physicalist approaches or dualist approaches or something else? Now, in this something else, instead of a drawing, I put a question mark The reason is that it's impossible to draw this approach. And why? The reason is, very briefly, the drawing is a model, and the model is a proof of consistency. And this approach is inconsistent. This is why we cannot draw it. So let's go into the detail. So problem 1, which computation? The problem of multiple computations or multiple causations. Which computation? There is a theorem, a well-known theorem proven by Putnam already in the 60s and still discussed extensively in philosophy of cognitive science, which is that the same physical process implements several computations, and there is no matter of fact as to which of those is actually taking place. Either all of them or none of them takes place. I will not go into this in order to save time, but will very briefly present in outline. I will not go into all these details here. Very briefly present this idea by an example. The example is following Oron-Shangri's papers from 2012. So a computation, a physical implementation of a computation consists of a physical system that follows the microphysical evolution, the microphysical trajectory according to the laws of nature. And this is one element of a computation. The second is a way to ascribe values, in particular 0 and 1, to this system, so that as the system evolves according to the laws of nature, the 0s and 1s change, and we seem to follow a computation, a physical implementation of the computation. So we need the dynamics, the value assignment, and together we have a computation. So here is an example of a dynamics. Without details, you can look at it this way. The A and B elements that go, I can't move with this mic. There is maybe, if this works, it will be helpful.
Turn it on.
Yeah, where is, yes, on. Never mind. So there is this gate, A, B leads to D, okay? And B are the input, D is the output. So here, A and B, the blue, the states, the microstates depicted by blue here, evolved to the blue out there. Thank you very much. Thanks. Okay, so the blue here evolves dynamically to the blue here. The orange here evolves to the orange here along D, and the yellows in A and B evolve to the yellows here. This is a graphical depiction of a dynamical law that follows the laws of physics. This is the dynamics. Now, this is not enough to bring about a computation. For this, we need value assignment. We need to be able to interpret the A, B, and D, these elements, as 0s and 1s. So we need to assign to the different values. Each of the elements, A, B, and D, can have 3 different physical states, X, Y, and Z. We need to assign the bits, the 0s and 1s, to the physical states, X, Y, and Z. So we can call X 0 and Y and Z 1, or we call Y 0 and X and Z 1, etc. This is, to a large extent, arbitrary. So here are examples. The value assignment 1 will be that X is assigned the value 0 and Y or Z are 1, and another value assignment is that X or Y are 0 and Z is 1. And we can assign different values in the same manner. Now, to follow the computation, we need to follow the dynamics given the value assignment. Together, this will yield the computation. And in this particular example, the result is this. I'm not going to go into this. I will only point out the following facts. If we take the physical evolution from A, B, and D, according to all the options are here according to the physical dynamical evolution that was depicted before. And we assign the values in the two different ways. So there are these 0 and 1 are according to the value assignments given here. Now, it turns out that this particular dynamics with these particular value assignments are such that given one value assignment, the computation is of the function end. And given the other value assignment, the computation is of the function or, with the same, exactly the same microdynamics. So we have a multiple computation by the same microdynamical process given two value assignments. Why should we care about this? Well, this often worries people in cognitive science, people who take the computational view of the mind seriously, because many people think that this might entail that the brain has two minds. If the mind or the consciousness at a given moment, however you prefer to see it, if the consciousness at a given time is given by a computation, is identified with a computation, then we have here two consciousnesses or two minds, two full minds, not a parallel computation, not multiple of minds that coexist in the brain. But whatever you take the entirety of mental things to happen in the brain, you have here two of those. So the problem is sometimes called the multiple minds problem. And the question is, which physical fact fixes the value assignment so that we can say that our mind at a given moment calculates or rather than and, or the other way around. And the solution that is quite easily given, at least easily prima facie, is that the distinction between the value assignments is the distinction between the sensitivities of two different measuring devices. Measuring devices can be sensitive to the, not sensitive to the distinction, for example, between Z and Y, but are sensitive to the distinction between Z or Y and X. And another measuring device will have a different sensitivity. It will not distinguish between Y and X values, but will distinguish between Y or X and Z. And so two different measuring devices will see, as it were, the same system in two different ways. And so for each of those measuring devices, the same system will look differently. It will look as if it implements a different computation. This is a perfectly physical account. Tell me the measuring device with which you're looking at the system. I will tell you the computation that you see the system as carrying out. But now the problem is that we have two measuring devices, and we have to choose between those. And the question is, which is the measuring device that fixes the computation which is our mental state? So two questions arise, or two problems. Problem one, what is the measuring device that measures our brain in such a way that it sees our brains as computing? Because without seeing as computing, without assigning values, we have a microdynamical system. There is no 0 and 1, and there is no computation. So we need something to look at us, to see us as having zeros and ones in our brain by this coarse-grained perspective. And we need to decide or to find out which thing it is that looks at us. So some people say, well, suppose that in the brain there are two subsystems. The one is the computing system itself, and the other part of the brain is the part that looks at the first one and sees it as computing. Here we should be aware of the homunculus. We should be very careful about that. But put that to the side, go to the second problem. The second problem is this. Suppose that we already decided on a measuring device. Suppose that there is a criterion for choosing a measuring device. I don't think that there is. But suppose that there is. Then the question arises, what does the measuring device measure? Well, measuring devices are macroscopic systems, and those can be seen in light of different macroscopic variables in various coarse-grained ways. This is analogous to the problem of value assignment reapplied to the measuring device. We can look at the same measuring device, assign to it different values, and when we do that, the same device will produce two different measurements. So choosing a measuring device is not enough. We should use, in order to see which is the correct value assignment for the measuring device, we need another measuring device. This leads us to a regress. And the result is that there is no way within physics to assign values to a physical system in order to make it implement a computation. That is impossible. There is a regress. This is not a well-defined notion within physics. What is the solution? The solution is to forget about the computational view of the mind and to replace it with an identity theory. Identity theory according to which we will find the mental in research of the biology, the physiology, the physics of the brain, and forget about the notion of computation, which is, as I said, not well defined, and maybe even worse than not well defined. So what we have here, the solution for both problems is that the physical aspect of the brain is the mental state. This is reductive type identity physicalism. As long as we are within this view of reductive type identity physicalism, the mental is identity physical. It is physical. It is physics of the brain. It's not about computation. Computation is at best a useful, convenient description of the mental physical aspects of the brain. It's not essential. The mental is not essentially computational. The mental is essentially physical. You can use computational terms if it's convenient, fine, but it's not very important. Unless you do that, unless you proceed, you move to identity, physical, reductive theory, when you're outside of the reductive physicalism, computation is either dualist notion if the regress is stopped in a non-physical way, if you just choose a measuring device by some arbitrary stopping point, you decide, well, this will be my measuring device. There is no physical way of doing that. This will be a dualist move of stopping the regress, or it's not well defined because there is a regress that is not stopped. The result is this. Recall question 1 for functionalism. We ask, which computation does the brain realize or implement, and which physical fact fixes this computation? The solution for problem 1 is this. In computational neuroscience, without identity physicalism, the fixer of which computation is not physical. This is a dualist mind-body view. If you accept this view, then brain research is irrelevant for studying the mental because the mental is not in the physics. The solution is move to reductive physicalism. Here, the mind is the brain or is in the brain, and the physical features of the brain are to be discovered by brain research. But here, as I said, computation is at best a convenient description of the mental physical aspect of the brain. This is end of problem 1 and its solution. Proceed to problem 2, which is the one described below, in virtue of which physical facts do all these cases realize or implement the same computation. This is, the problem here is called the problem of multiple realization. Multiple realization is the realization of the same computation by these different physical systems. Okay, here there are two options. One is that the fact that is shared by these three things is a physical fact. They have a physical property in common. But this is reductive type physicalist view. This is not functionalism. This is not multiple realization. This is not the computational theory of the mind. So we don't go for it because we want to study what goes on in the non-physicalist view. So option 2 is this, and this is a very subtle and important point about functionalism and about multiple realization in general. The idea is this. If we don't go for identity physicalism, if we want to allow for multiple realization, genuine multiple realization here, then we have to accept that all these cases, A, B, C, as well as D, which does not carry out the computation, all of them are physically heterogeneous to the same degree. That is, they do not share anything that is relevantly physical. If these three are to some extent similar, then I would say that being to some extent similar is being identical in that extent. So similarity is rough identity, and rough identity is identity of an aspect. So we cannot, if we want to really genuinely accept functionalism, if we want genuinely to accept the computational theory of the mind, we have to assume that in all these cases, there is nothing that is physically relevant that is shared by all these systems. Nothing. And since nothing is shared by them, they are not more heterogeneous than they are heterogeneous relative to something that does not carry out this computation. This heterogeneity is crucial. Without it, you cannot even start the functionalist view. So you have to accept it. Okay, so we go for this. We go for the heterogeneity, physical heterogeneity option. Here, there are two problems or two questions that need to be answered. One, why are physically heterogeneous things implementations of the same computation or the same mental state for that sake? Problem 2, why are A, B, and C the same as far as computation is concerned? Why do A, B, and C implement the same computation and D doesn't? After all, D is as heterogeneous relative to A, B, and C as the three of them are heterogeneous one relative to the other. And this is crucial. Without this, there is no functionalism, as I said. So why A, B, C are of the same kind and D isn't? We have to answer this question if we want to accept functionalism of any sort. Well, one possible response is this. True, A, B, and C are totally physically heterogeneous, but we look at them, and for us, they look the same. Fine. So here is us. So these three eyes are red. This isn't. So to us, these three look the same. For example, we causally interact with these three things in such a way that in us, they make the same impression, whereas the physical interaction with this one creates a different impression. So the shared thing between A, B, and C is us. Actually, what we have here is an extended system. We no longer have brain, octopus, and motherboard. We have brain and observer, octopus and observer, motherboard and observer, extended system. But those extended systems are no longer heterogeneous. They share something, namely the brain of the observer. So the brain of the observer is shared by all these cases, but then heterogeneity is lost. This account is a physicalist account. If you add an observer, you extend the system and you say that the state of the brain of the observer is shared in all these cases. This is not a case of multiple realization. This is a case of identity physicalism, and I'm fine with that. We want heterogeneity. So here, the extended system, what's going here? Yeah. The extended system is not physically heterogeneous. This is not genuine multiple realization. If we want genuine multiple realization, we need the observers to be different as well. So we have three, for it, we have extended systems, fine, but they are heterogeneous, they don't share anything. And then the question reappears. So as long as we add something to the system, as long as we extend the system by adding something physical, an observer, measuring device, whatever that is, which is not heterogeneous, we're back to identity physicalism. We don't want that. We want genuine multipolarization. We want the computational view of the mind. So the only way to overcome this is to say, well, you know, forget about all these observers and measuring device. The fact that A, B, and C carry out the same computation is just a brute fact. And the term brute fact appears in the literature, in the philosophical literature. But brute facts is non-physical facts put in a nicer, more scientific-looking terms, perhaps. Brute facts, which provide genuine multiple realization, are facts that are not physical, and therefore we do not require them to be physically heterogeneous. They are just brute facts somewhere. They cannot be physical, because if they were physical, we would require them to be heterogeneous. So in order to solve this question of why same computation, and if we want to do it in the framework of genuine multiple realization, in order to take very seriously the computational view of the mind, we need to be dualist. And here this is, you know, really substance dualist, perhaps, not perhaps, you know, if some people are happier with property dualism, whatever, it's the same. These are non-physical facts about the world, without which the computational theory of the mind cannot be maintained. To sum up, recall that we had these two questions: which computation, and in virtue of which same computation. Recall the response to problem 1. We said that the fixer of which computation in computational neuroscience is not physical. This is a dualist view, and therefore in this approach the brain research is irrelevant for studying the mental, and I propose replacing this view with identity physicalism. It's nice to discover that the solution for problem 2 is exactly the same. The problem is the same, and the solution is the same. In computational neuroscience, the fixer of shared computation is not physical. This is a dualistic view. And if dualism is the case, then brain research is irrelevant for studying the mental. And again, we propose to replace this functionalist view with type identity reductive physicalism. That is, to carry out brain research not in terms of computation, but in terms of the physics of the brain, the biology of the brain, the physiology of the brain. This is where the mind should be found in a non-dualistic way, a well-defined view. So the answer to the question of is the mind in the brain according to contemporary neuroscience, the question is, it is not in the brain in computational neuroscience and other forms of functionalism that allow for genuine multiple realization. It is in the brain in reductive identity, physical or physiological study of the brain. Thank you very much.
Thanks, Orly. We have time for questions. You can take
Can you give me the water? I can't walk with this. Yeah, thank you. This? Ah, okay, great. Now you tell me. Okay. Rafi, you take what? Yeah. Okay.
So, yeah, you reject functionalism. I mean, I suppose that, well, since Searle, this argument against computational, a full computational explanation of the mind has been around, but the identity theory also has a lot of problems. So if you take identity theory, you would deny mind, let's say there will be aliens, and they will behave like us.
Mm-hmm.
Therefore, you have to, I mean, from a functional perspective, you will say, well, look, they behave very, you can assign to them functional states because they seem to be like avoiding pain and they try to strive for things.
Yeah.
So there are all those computations which you can behaviorally,
Yeah.
I mean, taking like a Turing approach or psychology approach,
Yeah.
you can describe computation to organisms even without getting into their brain,
Well-
just from outside.
Well,
But then you will
yeah.
have to deny that it's possible to understand minds by any kind of behavioral observation.
That is not the case. So there is bad news and good news. The bad news is that this line of thinking is not open to you if you want to be a physicalist. If you are willing to accept non-physical facts about the world, then this line of thinking is open to you. This is, I call it the bad news. Some people will think these are good news. The good news for the reductive physicalist is that it is perfectly possible, even not very different from what goes on in actual physiological research of the brain, to explain aliens, robots, other minds, and so forth. In fact, reductive physicalism is the only solution to the other minds problem, by the way. So the account for the alien will be the following. Option 1, the alien is, let's call it a robot, that mimics our input-output behavior without having a mind at all. This is option 1. I don't see why this shouldn't be the case. Option 2, the alien does have mental states. In that case, somewhere in its physiology or its environment or what have you, in a distant quasar, there is something that is relevant to the mind of that thing. And the thing which is the mind, is a copy, a precise replication of the thing in physics, which is your mental state. This is an identity theory. There is an aspect of your brain which is your mental state, and this aspect is copied exactly in that thing. Now, copy, I don't mean that it has, this wetware that we have. It can be made of anything, but we know from physics that there can be systems that look very differently, but they share a function of their microstate.
So you need some kind of isomorphism, but it...
Copy is much stronger than isomorphism. Copy, a precise replication.
But then it has to be carbon-based.
No, it doesn't, because some features of carbon may be the same as other molecules. So you can have a very different chemical substance that replicates, copies the precise same physical, if you want subatomic, whatever it is, feature, which is your mental state. The idea that in order to have type identity physicalism, you need to have a physiological similarity is an error that was implanted to the literature by Hilary Putnam. This was a great mistake that led philosophy astray for dozens of years. This is mistaken if you look at what physics is, what a physical state is, and you take your lesson from branches of physics, in particular statistical mechanics. So this, from physics, we learn that this is totally mistaken. And what you do in biological, physiological study of the brain is look for that feature of the brain, and if you want, copy it to something else. I'm not against it. Of course, as I said in the beginning, you can opt for the computational view. Fine. If you are willing to accept that there are non-physical facts in the world, fine, go for it. I don't know if we are, yeah, okay, so please. Yeah.
Okay, well, I'm not that big a fan of functionalism either, but of course, given this problem that was just discussed, how are we ever to find out which are these physical facts in, say, in the brain or in any other system, without resorting to any kind of functions that, I mean, for example, people saying, I had a conscious sensation of this or not.
Yeah, it's, well, I guess there is still a long way ahead of us, but we can learn from the history of physics. Here is an example. During for millennia, or in at least a few centuries, people talked about heat. And during the 19th century, people developed the thermodynamics of the theory of heat, and they talked about all kinds of options to account for heat, for example, by a substance called caloric and so on. And at some point, people had the idea that heat is nothing above and beyond the basic constituents, that is the particles that they thought the world is made of back then. And they were looking for an aspect of the microstate of the world, which is the heat. And for example, the famous example is for an ideal gas in equilibrium, heat is average kinetic energy of the molecules of the gas. Now, there is nothing in the concept of average kinetic energy of molecules that resemble the intuitive notion of heat. But according to physics, average kinetic energy of the molecule just is the heat. There is nothing, it doesn't give rise to heat. It is heat. And this discovery is highly non-trivial. It was very difficult. Of course, I guess it's much easier than finding the features of the brain. Fine, go to work.
Okay, but we can observe heat, and observe these molecules, and then see the identity.
I do not think so. I think that when you observe heat, the thing that you observe is directly the average kinetic energy of the molecules. You do not observe heat and average kinetic energy of the molecules. When you observe heat, you learned through science that what you observe is actually the average kinetic energy of the molecules. You call it heat, but fine, that's a name. So when we will learn about the brain, that when we talk about sadness, we actually are talking about the brain thing. The brain thing, it does not give rise to the sadness. It just is the same thing. Exactly as in heat, there is no heat above and beyond that thing down there.
So just to clarify, following this heat example, so two elements that have exactly the same heat, will you call them a copy of one another? Because the microstates are very different.
That's right. I will say that the heat is exactly the same. So it's not...
let's say mental state is heat. You will say then the two elements have mental state, despite the fact that they have very different...
Yes, they will have identical mental state. It will be the same, indistinguishable, the same thing exactly.
But the microstates are different.
Yes, the other features. Some of the microstate is responsible for that mental state, and then it will be an exact copy. The rest of the microstate is irrelevant for that. Fine. Let me go to, okay, yeah.
Can I defend computational neuroscience?
Sure. If you can. You can try. Yeah.
In this business, but I thought I was actually quite happy, or my computer stopped up, but I was quite happy with your description of computation as approximate description of what the physical system is doing.
Yeah.
I think that's what we do in science. And I'm a bit surprised you mentioned the heat example, because it's an example of an approximate computational mathematical description of what the physical system is doing.
What, the heat?
Yes, it is a mathematical
I disagree.
description. It's by the mathematician. It's very similar to what we do in computational neuroscience. We describe a computational state.
If it's the same, then I'm happy. Then you're not doing computational neuroscience, but identity theory.
Well, I think we are doing an approximate description by mathematics. But
No.
second, I think you left out something very important for biology, which
Yeah.
is evolution. With evolution, the system of animals approximated better computations. And I think that's why computational neuroscience is so powerful, because there are actually computations that make organisms successful, and these are the ones that were selected. So you look at a predator catching a prey, the computational description is excellent. You have systems in the brain tracking the trajectory, the speed of the prey, and you have systems matching it with the predator and so on.
Yeah.
I think the computational description is much better than you think it is.
First of all, computational description may be very convenient. But then you first of all have to choose which computation is carried out. And this you cannot do unless you opt for identity theory. This is why you have to assume identity theory if you want to use this convenient way. With respect to the evolutionary perspective, I'm more suspicious in the sense that, regardless of the evolution, I want to understand the system as it is now, and selection in order to achieve something is something that is teleological. I'm a bit suspicious about this, but we can talk about this. This is not main here, so we can discuss this later. But it seems to me from what you're saying that this is essentially identity theory. Look, if people here are saying that they are using the computational terminology as a convenient way of describing something that they know is there physically, then I'm fine. I said this may be very convenient, but the selection of which feature, which aspect, what is the value assignment is done not within computationalism. You need to step out of this and opt for identity theory. Then use computation. I'm not against it. It's a nice tool. Who knows where it will take us? But it will not tell us what is the mind, because the thing which is the mind has to be finally at the physics. Rafi, you tell me when to stop. So, yeah.
You have time.
Okay. Yeah. So,
Liad?
yeah.
I'm also not a big fan of computationalism, but I have two concerns. First, with regard to the multiple computationist problem, I'm not sure if the problem is with computation as much as it is with motherboard analogy. The idea that computation requires fixed gates, right? And the input is dynamic is one thing. It can also be that maybe the complex dynamic system, I don't know, that it's conceivable at least that the gates themselves are part of the input, let's say, or can be.
Sure.
And then I'm not sure how the multiple computation problem arises. And the second thing with regard to
sorry, just so that I don't forget, you're saying that the input is imposed by the environment or something like that?
The input inside, like
what's the input
computational
inside?
process itself, like
Yeah.
whether it does and or for example,
Yeah.
it does depend on the input,
That
or on another input, on the third.
on the value assignment only in my example.
But I'm saying that the gate itself can be part of the value assignment.
This cannot be the case given the physics that I just described. Whether the gate is an AND gate or OR gate does not depend on the environment nor on the physics of the gate, but only on the value assignment. And the question is where it comes from. So here I have to insist.
And
We need-
just one other. I'm afraid that with the identity theory, it actually makes the whole notion of computation senseless. Because if our brain is, like, if it's identical, and we look at the computer, then what assigns the value there? Nothing assigns the value there, so it's all just a big mirage.
Fine, I'm fine with that, but I'm not against, whatever works within science. I don't want to tell scientists what to do. If it's convenient, fine, but it's not essential. I'm with you on that.
We need to continue. Thanks for a very lively starting and a good energy. And I'm pleased to invite Liad Mudrik from Tel Aviv University, and she'll talk about theoretical versus operational definitions of conscious and unconscious processes. Are we studying what we want to study? Liad? יש לך את הרמקול? The speaker speakers are asked to move to the reserved places to leave room for the...
Okay.
Yeah, just 1 second.
Dominique.
Reserved, unreserved.
Reserved, unreserved. Dominique, תבואי.
יופי. וזה פה. מצוין. Okay. Can you hear me? No. מצוין. Okay. So, hi everyone. What I'm going to talk about today is more of a methodological point, but I think maybe a substantial one, about the way we study conscious and unconscious processes. And some of the things I will say might be a bit provocative, but I hope you will get them, you will accept them with a sense of acceptance. And I'm happy to debate over them, and I'll try to leave as much time as I can for questions. But in a way, it kind of represents, I wouldn't say an existential crisis that I've been experiencing, but some kind of a crisis as a researcher trying to understand consciousness and asking what types of tools do we have in order to answer that question. So I'll first introduce the problem, and then I'll try to describe 3 ways by which we try to address it in our lab, by changing the stimuli we use, changing the methods we use, and also changing the questions that we ask. So I'm going to start with the well-known metaphor of the iceberg, suggested by Leibniz and Freud and others, whereby conscious processes are only the tip of the iceberg, the thing that we experience, but underneath the surface of the water, there are many unconscious processes to which we are unaware, and they influence our behavior. And one very interesting question that I've been trying to pursue is what is the difference between these 2 types of processes? Neurally wise, but also functionally wise. And I'm not talking about functionalism versus identity theory here, but in terms of psychological functions or cognitive functions. Throughout the years, there have been many suggestions that try to dichotomize the difference between these 2 types of processes, claiming that conscious processes are integrative, while unconscious processes are encapsulated. Conscious processes allow flexibility, while unconscious processes are habitual, the types of things that we do without flexibility. And the conscious processes are controlled, while unconscious processes are automatic. These are just a few examples, but there have been other suggestions as well. And it seems as if the field in the last 2 decades or so has been racing towards showing that these dichotomies are false. So different people, myself included, have tried to say, well, no, consciousness might not, unconscious processes might also allow some form of control. Unconscious processes might also allow some form of flexibility. And unconscious processes might allow some integration. I once thought it was high-level integration. Today I'm more modest in that respect and think that maybe this is not the case. But in any case, all these papers and all these works have made people question these dichotomies and ask, maybe unconscious processes can do everything that conscious processes can do. And I think a very interesting and thought-provoking suggestion for that approach was Ran Hassin's Yes It Can paper, claiming that indeed everything that we do consciously could also be achieved unconsciously to some extent. But then I said, let's stop for a minute and try to think of how we tackle this problem. So what are the tools that we have in order to ask this question? So typically what we do is we show a subject some stimulus consciously, and we record either the neural activity or the behavioral response to that stimulus. And we know more or less what to expect when subjects process that kind of stimulus. And then we render that stimulus invisible using different techniques. And we ask, do we still see the same or some brain response that would serve as evidence for that person processing that stimulus, or some behavioral response that would do the same? And in order to render the stimulus invisible, we have different techniques in our toolbox. And I won't go into that. There are many nice reviews, some of them written by people who are sitting here, about the different ways we have as experimentalists in order to render stimuli invisible. So we can embed a stimulus in noise. We could mask it, so show it very briefly between meaningless stimuli to prevent the conscious perception of it. We could crowd it, present it in the periphery, crowded by masks or flankers. We could use continuous flash suppression, where one eye is kind of bombarded with colorful stimuli that are flashed, usually at 10 hertz, and that would render the other stimulus presented to the other eye invisible. It's a variant of binocular rivalry. And we could also use attentional manipulations, like the famous gorilla experiment, which would make subjects not see the gorilla. And we've been using these techniques for a lot of time. To this day, in my lab, we have many experiments using these types of theories. Techniques. I won't go into details, just to give you a taste and also maybe to invoke discussions later on over lunch or during reception about some of these things that we do. So Amir Tal and Oren Beirav have tried to use CFS in order to show that there might be contextual learning without awareness, and we found some evidence for that. We are now trying to replicate that, and if that would indeed be replicated, I think it would be a very interesting finding that subjects can learn a context even though they are unaware of it. Itai Linzen and Alisa Truman and Inbal Gurarier are trying to continuously probe this question of context-object integration without awareness. Today, we have more and more evidence that there shouldn't be or there isn't such type of integration without awareness. We also now show it with EEG. And Dan Biderman and Yarden Shir have used masking in order to mask contextual inducers like A and B that are or 12 and 14, while the ambiguous stimulus, the famous B13 stimulus, is visible. And what we show is that even when A and C or 12 and 14 are invisible, subjects are still affected by them when they say whether this stimulus is a B or a 13. Now, just to show you, this is the conscious effect. This is the replicable but unconscious effect. And you can see the differences between the magnitude of the effects when this is visible versus invisible. So yes, it seems like maybe subjects can integrate contextual cues and be influenced by them when they classify or perceive an ambiguous stimulus, but the extent of the effect is way smaller. And this is one of the things that I keep working on these effects. I keep getting these very small effects, and some of them do not replicate. It's kind of like a minefield, experimental minefield. So this is one fundamental problem in our field, that we have very, very weak signals because we impoverish the stimuli that we are using so much. Another problem that we should take into account is that even after several decades of this type of research, we still don't have a strong agreement about how to operationally define what is conscious and what is unconscious. Are subjective measures enough? Do we need to add objective measures? And even if we do, what happens when we exclude subjects, like the criticism made by Shanks recently? So we keep kind of stumbling upon methodological limitations or questions that render our attempts to directly probe conscious and unconscious processes a bit more problematic. Even more important, I think, is the meaning of these results. So we showed that you can integrate a context without awareness. But what is the fundamental meaning of this finding? Or that some other people claim that we can read or do math or process emotion and so on and so forth. Here I like to quote a metaphor that was given by Hakwan Lau, and I think Christoph Koch also suggested that. Let's say that we are asking what is the function of legs. And in order to ask that, we take a subject. Let's assume that we could do that ethically. We cut off that subject's legs, and we show that that subject can still move in space. And then we would say, well, the function of legs is not to move in space. And for us, this seems flawed, but this is exactly what we do with consciousness. So we take a subject, we cut off her awareness using these techniques, and then we show that she can read or she can do whatever, and we say, well, we don't need consciousness for that. I'm not sure that that logic holds. It might be that in everyday life, this is exactly what we do. We use consciousness to read, think, compute, whatever. But in some specific lab setting, we created a situation whereby subjects will be able to read without awareness. I'm not sure that it says something about the computer is now angry because I'm making all this. Okay, let's see if it comes back to life. Exactly. And I think, and maybe the most critical point, and the one that people here might not really like, is that I'm not sure that our tools have a strong external validity. So when I inspect the difference between the theoretical construct that we want to study, which is conscious versus unconscious processes as they unfold in everyday lives, and the way we probe it in the lab, to me it seems as if there is a big difference between the two that might even transcend what we always have. So always in psychology, we have to operationalize the theoretical constructs that we work with, right? So we want to study memory, we give lists of words. We want to study conformism, we create a situation when everyone says one thing and the subject is then probed to say either the same thing or another thing. But here, I think the operationalization and the ways we found to study consciousness are very, very far from conscious and unconscious processes in everyday lives. So in everyday lives, we never, almost never, see a stimulus for 17 milliseconds embedded in noise. We surely never we are never presented with two different lines of stimulation to the two different eyes. So it might be that we were able in the lab, and it's an amazing, I wish I was smart enough to invent such a technique. So these are all extremely elegant, well-controlled methodologies that allow us to indeed experimentally tease apart conscious and unconscious processes. But I think the cost of that is that it drew us somewhat far away from what happens in real life. And I would claim that in real life, it's actually the gorilla experiment that is most similar to what happens when we either consciously or unconsciously perceive a stimulus. So actually, attentional manipulations might be better off here. So in a way, if we go back to the iceberg metaphor, this is a picture, it's not a good picture, but it's the only one I found for a synthetic polymer that is used in order to create artificial ice skating arenas. So, and this is what people kind of import in order to have some experience of ice in iceless countries. The idea is that it seems to me as if we have all been focusing on this artificial ice, while what we really want to study is the actual iceberg. And we've been making claims about conscious and unconscious processes in real life, while in fact we have these, again, highly elegant, beautiful psychophysical manipulations that create some sort of conscious and unconscious processing in the lab that I'm not sure that it transcends outside the lab. And a friend of mine called me, I think it was 2 years ago already. I keep using that example because I like it. She called me and she was furious after this parent-teacher meeting. And she said, well, the teacher says that my son cannot focus in class and he might have ADHD or something like that. And I told her it doesn't make sense because at home in front of the computer, he focuses for 3 hours playing the video games. And what I told her was, well, first of all, I empathized with the situation. But later on I said, well, maybe because there is something different that happens to us when we sit in front of a computer as opposed to what happens to us in the outside environment. And it also might be the case here. So it might be the case that with CFS we can do amazing things, or with masking, but maybe that doesn't transcend or translate, that's the word I was looking for, to what happens in everyday life. So I will try to present 3 ways by which we try to attack this problem. So I've been kind of picking the brains of my students and forcing them to think of ways to study consciousness differently. So one of them, Uri Koriski, said, well, why don't we try, instead of masking things on the computer, why don't we try to mask things in the environment, real life things? So now change the stimuli that we are studying. And in a collaboration with the Shiva Hospital and 2 other students, Dan Biderman started this, and now Ronnie Hirschhorn is doing it, try to change the methods. Maybe we can, also Itai Aron, who is sitting here, is working on this project. Maybe we could try to create, to simulate real life situations that are more similar to the gorilla experiment, where we could probe unconscious processes that are more reminiscent of what happens in everyday life. And the last thing I will briefly describe is how we could also maybe change the questions. So let's start with changing the stimuli. What Uri suggested was, let's try to focus on real life objects. And we know already from previous literature that real life objects are different from 2D representations of these objects. So they are learned earlier, they are remembered better, they grab your attention, and they even evoke different neural activations. So what Uri said was, let's try to take the CFS, an artificial methodology, but use augmented reality so we could now suppress real-life objects. So what happens here is that she's using, Felice is wearing augmented reality goggles. One eye will be presented with CFS, the other, this one I think, the other would be completely transparent, so she could see the actual objects that are presented in front of her. And I'm not sure you can hear the sound. You cannot. Well, I'll tell you what's going on. So she is now, this is what she sees on the goggles. This is just a small display that we built for this small demonstration. And what would happen next, a bit unfortunate we cannot hear it, but never mind, is he's now explaining to her what is about to happen. And now the display starts. She will, first we kind of block out her vision by making the goggles white, and then we present CFS on one goggle, and the other is now becomes transparent, and there is a small rubber ducky, and she won't see the duck, and then Uri puts his hand, moves it, he even puts his face, and she still doesn't see anything. And when he just asks her to close one eye, the eye where the CFS display is being projected, she's laughing, you cannot hear it, now she sees his face. So now we are able to suppress real-life objects. What the subject sees is we have this device, a more serious device than the one that we showed you before. We have the curtain, it comes up, and then the CFS display starts, and at some point, the stimulus will emerge into awareness. So the first thing Uri did was to try and validate this methodology. So our lab became into some kind of art workshop thing. He collected objects, real-life objects. He then photographed with a professional photographer these objects in the device. He then went to a graphic designer to create 2D replicas of the 3D stimulus. So this is the actual Hungarian cube, Rubik cube. And these are 2D replications of that cube. And the first thing we wanted to see is whether we can actually suppress these objects. And we can. So when we present the CFS stimulation for 5 seconds, in about 75% of the trials, 80% subjects just don't see the suppressed stimuli. And for these trials, they are a chance in saying whether they were presented to the right or to the left. And there was an interesting observation here, Ronnie Hirschhorn also helped, is that it seemed as if real objects were perceived in more trials than the 2D representations. And then we kind of set off into a different exploration to ask, well, maybe 3D objects emerge into awareness faster than 2D representations. So what Uri did was to present now the CFS for 20 seconds and just measure the time it takes to this stimuli to emerge into awareness. And first of all, we saw that even with this method, with the augmented reality, we get relatively long suppression duration, so about 6-7 seconds. And again, we have this difference. The real objects emerge into awareness about a second earlier than the 2D images they are just, we glue them on these cardboard, so they are presented there on the device. So then what we asked was, what drives this effect? Is this some low-level thing that makes the 3D objects emerge into awareness faster? Or maybe it's related to, for example, affordances. So the motor plans that each object affords to us when we see it as part of its representation. So in order to test that question, what Uri did was actually to create 3D models of all these objects. So, and then he 3D printed them. So for each actual object, we had a printed version. And why did we need that? In order to create scrambled versions of these objects. So now we have a 2x2 design where we have real objects and scrambled objects that are either 3D or 2D printed. All of them are printed, so now we don't have any difference in reflectivity. So one of the reasons we said maybe this faster emergence into awareness is induced by some, flashy part of the real objects that do not happen to be the case for the 2D objects. So this will, if the difference is only because of reflectivity, there should be no difference between 3D and 2D images. Another option is it's just a matter of depth. So even though subjects are only seeing it using one eye, it could be that using perspective cues, they still infer the depth somehow. So it could be just a matter of 2D versus 3D. So if this would be the case, we would expect the two types of 3D stimuli to emerge into awareness faster than the 2D images. right? And the most interesting, I think, option for us was that it might be related to affordances or the meaning of the stimuli. And if this is the case, we should only find the effect for intact stimuli. So only real-life 3D objects that are meaningful would emerge into awareness faster. And Uri conducted 2 experiments, and this is what he found. Now, Uri is very complicated, so he also prepares complicated figures. I will try to, but that only shows to his complexity of thinking. So I will try to show you what we see here. So these are 2 experiments, 20 subjects, 50 subjects. Let's focus on, because we know how to interpret bar plots, right? So there is a difference between the 2D and the 3D, with the 3D emerging faster for intact objects, but not for scrambled objects. What you see here in the big plot, so the x-axis is the difference between 3D and 2D for intact objects, and the y-axis is the difference between 3D and 2D for scrambled objects, meaning that, and these are the means, these are individual subjects, these are the means. Everything that, basically every dot with respect to the x-axis that is left to the 0 point means that the 3D objects emerge faster than the 2D objects. Everything that is on the middle, this actually was supposed to be here. So everything that is on the 0 line for the y-axis is 0 difference between the scrambled and the between the 3D and the 2D stimuli for the scrambled condition. And what you can see is that there is a divergence from the 0 line for the x-axis, but there isn't one for the y-axis. So this is basically the same figure, but shown for individual data. In any case, what this implies is that indeed 3D objects emerge into awareness faster than 2D objects, only for intact stimuli. Why is that interesting? First of all, because it might tell us something about the way we unconsciously process affordances, but also because what Uri can now do is use this newly developed method in order to ask questions about, first of all, more salient stimuli. So we think that we might be able to overcome some of the issues with the weak stimulation, because now I can present to study emotion. I should not suffice with just presenting a face on a screen that shows anger. I could actually show an angry person to that person, and the person would not see it, the subject. And more importantly, we could test theories like the 2 visual streams. So if indeed we have vision for action and vision for perception, maybe subjects like patient DF would be able to take a card and insert it into a slot, although they don't even see the slot. And if we are able to show something like that, or even something that seems to go in that direction, that would be a very strong evidence for the separation between vision for action and vision for perception. So the idea is that this kind of technique allows us to ask questions that before we could not ask. For example, what is the role of conscious perception in action, in interacting with your environment, and not only with seeing stimuli on screen? So this is one approach. The second approach is to use the methods and to rely more on attentional manipulations when we study consciousness. And I know some of us in the room probably would not like this approach. But again, I would claim, and I'm happy to defend that claim, that it's more similar to conscious and unconscious processes in everyday life. And we think that that would also help us attack the weakness of the signals. So the idea was, what we try to do is to try to mimic the gorilla experiment. But the problem with the gorilla experiment is that you do it once and then you always see the gorilla. So the question is, how can we create a situation where subjects keep missing the gorilla although they are asked? We have to ask them to know whether they saw it or not. So what Dan Biderman started to do, and now Ronnie Hirschhorn is doing in collaboration with Meir Plotnik at the Sheba Hospital, is to use, they have this 3D dome where they can project an environment on a 360 degrees screen, and it interacts with the subject. So it's a form of virtual reality, but actually projected on a screen and not using the goggles. And basically what we did there, and this is very preliminary, we are trying to improve it all the time, so it takes time. We have subjects walking, and there are 3 bees. You will see it in a second when the video starts. So there are 3 bees that are moving on the screen all the time. And the subject's task is to focus on one of the bees that we signal out. So she is kind of going over them, and she, at the end of the trial, she should say which of the 3 Bs was the one that we marked at the beginning. And in the background, we are presenting images that are either neutral or very emotionally aversive. At the end of the trial, she's walking down the street. At the end of the trial, we ask her how much of the, if she saw any ad that is not scrambled, and if so, to make a discrimination between 4 such ads. So just to show you how this goes. Okay, so she's walking. We mark one of the bees, and now the bees start moving. And while she's tracking them with her eyes, we project on the environment either a scrambled billboard, a scrambled image, or an intact image. You can see that the images are big. They are in the periphery, of course, and we make sure that the bees would actually fly over these billboards to make sure that the eyes actually get to that point in space. And we do that repeatedly. And what we get at the end, we get about 75% of trials where she misses. She says, I didn't see anything, any such image, although it's big and presented here. And when we ask her to say which one of 4 images it was, she's a chance in these trials where she says that she didn't see anything. So this is very preliminary still, but we think that it simulates everyday life much better than what we typically do in the lab, because this is basically what happens. I walk down the street, the environment is rich, I miss some of the things, I see others, and so now we can ask, can we indeed read without awareness? When I'm going down the street and there are billboards on the side and there are words written there, if I don't see them consciously, I don't experience them consciously, do I still process that information? I am not sure that what we find in masking and CFS would actually extend into these types of situations. Maybe it will. But I think it's important to ask the question and not just assume that this happens. It might evoke stronger effects because the stimuli are way more salient. And the idea is to apply in-lab measures of objective and subjective tests of awareness on an out-of-lab study. But we use attention. So for some, this is a problem because they say, well, you're actually studying attended versus unattended. My answer would be yes, but in most cases, I think, in real life, this is the gate to conscious and unconscious. So I'm happy to pay that price. In the few minutes I have left, I will just describe one other way that we can make our studies more ecological is to change the questions that we ask. And this actually relates to the free will debate, not to perceptual awareness per se. It's a work in collaboration with Uri Maoz, done with, in Christoph Koch's lab with the help of Ralph Adolphs and Gidon Yaffe, who is a philosopher from Yale. And this basically follows on the famous Libet experiment, where, as you know, subjects were asked to move their hands. He recorded brain activity and found the readiness potential to precede the conscious intention to move by about 500 milliseconds. This was later replicated, as you know. Going back to the iceberg versus artificial ice metaphor, people are making claims about free will based on these types of experiments. But free will in real life and actually also in philosophy, when applied to moral philosophy and to ethics, is about actual decisions that have consequences. It's not about sitting in the lab and just moving your hand whenever you feel the conscious urge to move. So the question is, could we extend our findings from this artificial paradigm? And it's so artificial that I can tell you from running it that when I tell subjects, just move your hand whenever you feel the conscious urge to move, they say, what? I don't know what you're talking about. I never feel a conscious urge to move my finger. Nonetheless, and then we ask them to say when that conscious urge happened. In real life, we don't first feel the conscious urge to move and then move. We typically just move. So this was based on philosophical differentiation between picking, which are decisions that are unreasoned and non-consequential, like going to the supermarket and selecting one milk bottle out of a row where all of them are identical, and choosing that is reasoned and consequential. So now I'm not sure which type of milk bottle I want, which brand, how many fat percentiles, and so on. So here we have reasons, and here we don't. And it seems as if the entire field of voluntary action has focused on meaningless, arbitrary decisions, while the conclusions we draw relate to meaningful and deliberate ones. So because I don't have much time, I'll just jump to what we did. Basically, we presented subjects with choices between two types of organizations, non-profit organizations. The choices were built based on ratings given by the subjects of each organization. So we presented each organization in isolation, and we asked how much would you like to donate money to that organization, and based on the subjects' ratings, we created a tailor-made experiment for each one of them. So we had difficult choices where, for example, you had to decide to which organization you want to donate money, and the organizations only differed in 1 point. And we also had easy decisions where the difference was 4 points or more. And there was one deliberate condition where when they actually made a decision, the chosen organization would get, if this trial would go into would be selected in a lottery, $40 in their name to that organization. And there was also a big lottery at the end where we chose one subject. So they had the potential of actually giving $1,000 to that organization. So they knew that every decision that they make might lead to an actual $1,000 donation to one of these organizations. And in the arbitrary block, they again pressed right or left, but now whatever they pressed, both organizations would get $500 if this trial would be selected. So the nice thing about this design, in my opinion, objective opinion, is that the visual input is identical in the two conditions. The motor output is also identical, but the meaning of the decision is utterly different. Here, it's a deliberate decision. Here, it's a completely arbitrary one. And what we get first behaviorally is that subjects are way slower for making the deliberate decisions, and they are slower for hard decisions versus easy ones. And there is no difference in the arbitrary condition, which of course makes sense. And also, when we look at consistency, in easy decisions that are deliberate, they are almost 100% consistent with their own preferences, which makes sense. If these are difficult decisions, they are at about 80% consistency. When this is a picking condition or arbitrary decision, they are more or less a chance. So they're not making decisions based on the values. What we get in terms of the brain is that for the arbitrary condition, and I'm showing you the individual data first because I think it's more informative, we get a nice readiness potential for most subjects. This is basically a replication of the Libet paradigm, but in a different setup. But in the choosing or the deliberate condition, we just don't get anything at all. So there is no readiness potential when subjects are making deliberate decisions. Now, it's not that I'm claiming here that deliberate decisions come from thin air. No, they come from the brain. And if we look at the right places, we would probably find processes leading to that decisions there. But it's not the readiness potential. And this actually goes well with the work, and this is statistically significant. This is already the average waveforms and the distribution. And this goes well with the work made by Aaron Sugar and Stanislas Dehanu sitting here, claiming that the readiness potential might not be a genuine component indexing an actual cognitive process, but it could actually represent some artificial accumulation of noise, just random fluctuations that drive the decision. Now, these fluctuations would drive meaningless decisions, and that's why they would average when we sum that up. But they would not be meaningful for deliberate decisions, because then the noise is not what drives us to make the action. So then they would average out, because sometimes the noise would be high, sometimes it would be low. So Uri Maoz extended the model suggested by Aaron Sugar into deliberate versus arbitrary decisions, and showed that it's actually very similar to the type of data that we got. So to conclude, I would finish with my favorite quote ever. I use it all the time. Many of you already know it. By Stuart Sutherland from the International Dictionary of Psychology. The year was 1989, so it's relatively recent past, in my opinion at least. And he writes in that dictionary, the definition of consciousness is a fascinating but elusive phenomenon. It is impossible to specify what it is, what it does, or why it evolved. Nothing worth reading has been written on it. Now, I think this represents the strong skepticism against the scientific study of consciousness that was the most dominant view in those days. And then the field had to kind of prove to all those skeptics that this is scientific, that we can study consciousness in the lab. And so they had to come up with all these genius paradigms in order to really control conscious versus unconscious and do it in the best and most elegant way. And indeed, we see many, many studies arguing about the best way to study consciousness. But my claim is that these all kind of might have took us too far from what we are really interested in studying, which is the conscious versus unconscious processes as they unfold in real life. So all these elegant paradigms are beautiful, and we use them, as I said. So I just presented 3 studies that we are now working on using these paradigms. But I think that in parallel, it's also time for us, the field has matured enough for us to ask ourselves, can we come up with new paradigms that are less controlled, but maybe pave the way to studying consciousness and conscious and unconscious processes in a more ecological manner. Before I give time to questions, just one more slide. This is complete like ad thing. So you might have heard about this project that Lucia and Stan and others and myself have been involved in, trying to tease apart two competing theories, GNW and IIT. I won't go into details. I'll just say that Michael Pitts and myself are now looking for postdocs to come and help us work on this project and analyze the data. And because I know that there are many consciousness lovers, either students or PIs, I ask you to spread the word. If you know of very talented people who are very passionate about consciousness, we are looking for these people specifically. So contact us, and thank you to all the people that have been involved in this, preparing this stuff.
Great talk, Liad. I'm joining the lab with this. So we have some time for questions. You take them.
Yeah, well, I'm obviously lazier than you are. And the 3D object that you showed did not qualitatively behave differently from 2D objects. They were different from scramble objects, just as 2D objects would be different from scramble objects. But I didn't see any convincing evidence that it is worth using them and that they behave qualitatively differently from 2D objects.
From 2D objects? So we see that they emerge into awareness faster.
Okay, so, well, just like bright things on the computer emerge faster than...
I agree. So the reason for us, so the faster emergence into awareness was for us just something that we found when we started to validate this paradigm. That was not the purpose of this paradigm. The purpose of this paradigm was to allow us to ask questions about conscious vision for action versus vision for perception, which I think is harder to do when you have only 2D representations. So now we have a paradigm that allows us to create a situation where subjects reach to grab an object that they don't see. This you cannot do. You simply cannot do with 2D, I think, with 2D stimulation.
You can, because our depth perception is 80% 2D cues. So, and it has been done before. So I'm not sure how much it's worth the effort. That's what I'm trying to clarify.
Yeah, so first of all, as you say, we love effort in our lab. But I think that what this allows you, so we already know from other fields of research that when you move to more ecological stimuli, you get different results. So we know that from interactions with on-screen actors versus people that are just in front of you. We see different brain activations. Also for objects versus images, we see different neural circuits, we see different attentional mechanisms. So it seems like there is something different in interacting with actual real things. And as specifically for the vision for action versus vision for perception, the only behavioral evidence that I'm aware of rely on visual illusions, showing that you can either grasp or not. But I think it's very different than being actually able to operate, to act on an object, which we just don't know. So the only evidence we have that people can interact with objects that they have no conscious representation of them is from lesion patients and so on. I'm not aware of any. If you know something, I'd be happy to learn about it. But to create a situation, a blindside situation, for example, where subjects could walk in a room although they don't see anything, I think it would be worth the effort if people can really do that. I just don't know. I only know that it happens for blindside patients, but I don't know if this transcends into healthy population.
Only if you get qualitative differences, and that would what I would like to see.
Yeah, so we also like to see. We'll see where this takes us. Yeah. Yes.
So you mentioned at some point brain activity might be stronger if we stop using subliminal presentations and go to actually find this? Because I surmise that this weak signal in the brain is really tied to unconscious processing, no matter how you achieve that unconscious processing. What is your experience here?
So we are still at the stage of behaviorally testing these paradigms. So we haven't started any neural kind of recordings with this. So I'll be interested to see how this works. But even judging from studies that use attention as a manipulation, you get stronger activations for unattended stimuli that are supraliminal versus subliminal, the stimuli that are rendered subliminal using psychophysical manipulation. So I would actually expect stronger signals.
So we subtract some unconscious processes out if we use subliminal stimuli, right?
Mm-hmm. Yes.
So we get rid of some unconscious.
Yeah.
That's bad for us.
Yeah, that's true. That's true. That's true. And this is, we are always on this, trying to get to this sweet spot where we get enough signal, but it's not conscious yet, but we still get, I completely agree. Yeah. Yes.
How committed are you to the idea that the dorsal strain is the provenance of affordances?
I'm not. So I'm just making my first steps in the field of affordances and dorsal versus ventral. My main passion is consciousness, conscious versus unconscious processing. This entire affordances kind of rendezvous happened while we were trying to develop this paradigm. So I'm still kind of agnostic about it. I'm looking into that, no more than that. Yes.
SSD, so you reject the efforts to approach to the preconscious processes. That's the distinction that John Barger had made in 89. And you claim that it creates some kind of preconscious phenomenon that has no external beliefs. And it's interesting to see why, at the beginning, why they turn to this level historically. Because as I'm familiar with the literature, so the researchers assume that, for example, if you take research about attitude, then they assume that if you approach to the real person and ask about his own attitude and try to measure it, then he won't give you any genuine answer. And this is why they did all these cognitive tricks and manipulation to reach the real attitudes that are inside us and are not conscious and so forth. So that's interesting to see according to what they made this turn and this assumption, and how what has changed that allow us nowadays to turn to a more conscious level.
So I think we should differentiate between two types of conscious and unconscious kind of dissociations. One is, I think, more on the social psychology level, where we try to differentiate between what we explicitly say and what we might implicitly think, or what implicitly drives our behavior, which I think is more related to the types of attitude research and barge studies that you're referring to. What we are trying to see here is more about perceptual awareness. So we are trying to take a stimulus and get it to a stage where subjects won't even know that there was a stimulus there, and ask still what types of cognitive, emotional, whatever processes we can perform even when we don't know that something was even presented. And I think it's a very interesting question to ask, what is the relations between these two types of fields who are not interacting to a great extent? Is the same unconscious processes that we study, that are more perceptual and cognitive, I would say, do they relate to the more social types of unconscious processes? I'm not sure.
Because you also mentioned the perception for action,
Mm-hmm.
the perception for
Vision.
perception,
Mm-hmm.
vision,
Yeah.
and some is more linked to behavior and some just for perception, but the assumption is that the perception of vision can also eventually lead to behavior.
Yeah, so it's a very good point. I'll be happy to discuss. We have time for... Yes.
One more question.
Yes.
You made a point about the difference between artificial things like CFS and natural things, but actually the difference is between explicit then implicit, you don't see it. So being aware of being unaware versus being unaware. So can you...
Yeah, that's a very interesting point that I haven't... so there is a lot of literature about what happens when we are forced to report whether we see or not see, and what types of engaging or confounding processes might be evoked by this type of task, as opposed to a situation where we're unaware and we don't even know, we don't introspect on being unaware. I think it's a very interesting distinction. I haven't really thought about it when trying to devise these experiments, but and because we force them to say, so we ask them. It's not a no-report paradigm, but it's a very good point that is also, I think, widely discussed these days with Ned Block and others claiming that we should probably avoid from doing that as well. But we're taking it one step at a time in that respect.
Let's continue this over coffee. We will be back here at 1:15.